enter the brand new field of hyperspheric space. We spent quite a while in discussing spheric space, and so it is a good idea now to just be sure of our axiomatic bases. There are essentially three in order to understand hyperspheric space. But what is it? What is the purpose of introducing this brand new geometry? It is in order to get a more firm understanding of Einsteinian spacetime, which, as you know, dominates physics now. It even is used at the quantum level because spacetime is thought to describe the actual structure of the universe. We can certainly say it's very close. However, it cannot possibly be adequate because it's a linear system. It's a system of four lines. Now what this does is it introduces the notion of time into space, which is superficially quite baffling because time does not have the characteristics of space. But the reason Einstein did what he did, which was quite a miraculous synthesis, especially in geometry, which I obviously am devoted to, since geometry is the way we understand things. We do not understand the universe through numbers. We use numbers to support the geometry that we adopt. So the Einsteinian field space construction is a hybrid geometry which cannot actually be understood or even visualized except through the use of projection, which is a rather old technique. It's hundreds of years old. The Italian artists used this geometry in order to establish perspective in their art, their flat space art. We draw on flat surfaces usually, but when we want to get depth, it's important to notice how the human eye perceives depth, and it is as a projective geometry is how it can be done. Projective geometry is also used in map making for the same reason, that it's a projection downward. We consider ourselves using our standard scientific construction. We concede that we see in 3D, which is a three-line system, which makes cubic space. But actually, that is not how we see, although we have two ways of seeing, and one of them does admit a construction of 3D geometry. So it's been extraordinarily useful, and it's also extraordinarily important to realize that that is the only geometry that has ever been used in science. So what I'm attempting to do is reconstruct our geometric and therefore our numeric basis to more conform with how we actually see, and in fact how the universe is actually perceivable. It is spherical, but we are in a sort of a conundrum, partly because of history, but it turns out that it's not really to be blamed on any arbitrary approach to geometry. It can be shown, as I have shown, that it was absolutely necessary to begin with linear geometry. But linear geometry must eventually be perceived to have an inherent weakness in that it cannot deal directly with curvature. It is highly advantageous, certainly in theory, I would have to say, starting out, to be able to have a geometry of curvature. This would be to reduce curvature to its normalized form, which in flat space would be the circle, which we obviously use quite extensively, but in real space, that is physical space, we perceive that spherically. The relationship between the sphere and the circle is rather obvious, and there are various ways to state it. I've gone to extraordinary lengths to extraordinarily I'll just say, specific techniques to define the relationship between the circle and the sphere. We have gone into that somewhat, but to get right to the point, hyperspheric space will be the correct construction of space in order to maintain two aspects of science, that is our scientific geometric basis. We need to retain linear numbers throughout the system. That's not a given. It is possible to construct other number systems, and one, I'll just say in particular, has risen to the top. It's not a linear number system. It's called the complex number system, and I've given several lectures on the complex number system because it's the only number system that's used in advanced science now. Of course, complex numbers have to be based on linear numbers because they have to be transformed into linear numbers, because linear numbers are computable numbers. That's why we cannot leave them behind. But it has been shown conclusively by John Horton Conway what we intuitively understood, but which Conway proved, which is that the straight line and our linear number system used exclusively in science, it is the way humans use numbers. It is called the linear number system. We do say that now because there's the complex number system, which is not linear. It has a transformer, a function which is built into the system, which is a new form of algebra. It's rather simple, but it is used in order to transform the complex numbers back to linear numbers. This can only be done through a specific form of multiplication, establishing a multiplication rule, which then relates the complex numbers, which are two-component numbers. You need two of them, and you need to multiply them in order to get rid of the I component, which is not a number. It's not a linear number. It's called an imaginary number for a specific reason, but that's not greatly important what it's called. It's what it is that matters. And so in the construction that I have made, I took into account the complex number system and the linear number system to preserve the best features of both. This is not something that I could have figured out. A discovery is a discovery of something that actually exists. It's not an invention. Now these days that has been extended in our advanced mathematical systems to mathematical constructions which are virtual representations of reality. And again, to make a long story short, the Einsteinian space system, his system of space-time, is a linear construction. It uses a form of complexity because the reason we use complex numbers is to get a circular function, not available in linear algebra except through the use of, algebra. But complex numbers are simply a shortcut. They do the same thing that linear numbers do, but by using the square root of -1 as one of the two basis axes, it enables the use of a special logarithm, and it is a logarithm called the natural logarithm. If you're acquainted with this, forgive me, but I do always like to be sure we're all on the same page as we begin a presentation. In order to get into greater depth, you don't want to leave a listener behind. Now that is a trade-off in that because you can't repeat everything. So this is a summary in order to introduce our topic. So one of the axiomatic bases on which I've developed a new geometry is a new number system. They are, as in the case of the line and the linear number system, I'm not sure I completed that sentence, but the reason we use linear geometry and linear algebra exclusively in science is because our number system and the line are identical. What I was able to prove in 2022 is that the sphere is identical with a spherical number system, and here's the important part to begin with. It is a linear number system. It's also a two-component number system, similar in that sense to complex numbers. However, instead of using an imaginary axis, the entire basis is spherical and does not use linearity. That implies a certain contradiction. However, it's not a contradiction to say that the linear number system is embedded. That required a very severe proof, a theorem that needed to be proved, that indeed the linear number system is embedded in spherical numbers. The reason for that is the same as for complex numbers. You need a specific rule in order that on the last step of your computations, you decompose either your complex numbers or your spherical numbers back to linear numbers in order to complete your computation, because only the linear numbers are computable. All right, so that's one of the bases of hyperspheric space, the number system. I hope I've explained that carefully enough. The second axiomatic basis is the geometry, which proceeds from, or is actually identical with, the number system. However, geometry itself has its own rules, which are conformable. That is, they do conform when the construction is correct. They conform to the number system. The rules of geometry can be treated as automatic as long as it's already been proved that the number system supports your relational constructions. This would be something like the Pythagorean theorem, which is a linear construction, but it works. You do have to prove that it works, and it's important to know the proof of the Pythagorean theorem. Now, in spherical space, we begin with a different concept of the line. There is no straight line. It is there and it can be found, but it is not the same basis. In other words, we use linear constructions, a 2D to 3D to 4D in the case of the EFE, that is a four-line system, in order to get at curvature. The universe is curved, and I don't need to keep harping on that. The proton is spherical, the atom is spherical, planets and stars are spherical, and the universe appears spherical, and it's important to put it that way because it also appears to have an infinite edge, which is quite a conundrum. However, I have solved that. There is now a rational definition of infinity, which makes perfect sense and actually solves a couple of long-standing paradoxes in science. Now, the way we look at scientific constructions, in our case, this would be for the universe itself and for macroscale objects such as galaxies and, in fact, anything in the universe. But going down to the microcosmic level, we're talking about atoms and the constituents of atoms. And so today, I'm going to talk about the standard model of particle physics. In order to do that, I did quite a bit of preparation. Although I, like many people, are quite impatient with bases and just axiomatic statements, it's quite suspect when you're going to study a system such as the standard model of particle physics. It can be quite frustrating to find an entry point because it's essentially an extremely advanced mathematical system. Although it relies on relativity and it does rely on complex numbers, it's standard. It's standard, but it's quite convolute. And the relationship between the actual physical phenomena and physical structures involved in particle physics, the relationship between those things and the mathematical constructions are very nearly impossible to fathom. It takes years and years of study to become a particle physicist because of the extraordinarily unapproachable nature of the mathematical system supporting it. There are reasons for the complexity, but it's not just complexity which is to be expected. I'll just say to some order of complexity. That's not nearly as much of a problem as is complication. Complication is much different from complexity. It's something we try to avoid in science because science is supposed to enable understanding. Now here, I just need to make a very quick comment on which I've spent far too many lectures elaborating because it ends up with me turning into a vent and a tirade sometimes, that the level of complication in the modeling systems that we now consider to be the cutting edge of science is far, far out of control. Far, far out of control. So I merely wish to state, so that you have, as I have come to have, a simple human understanding of why things are as bad as they are. The level of complication is orders and orders too high. Something has gone violently wrong, and obviously has gone wrong at more than one level. Not to worry, I myself have gotten down to the basis of the essential errors that redirected science into this cul-de-sac where science can no longer get out. The cosmological model needs no comment. It simply cannot be understood, and it's not correct. The standard model of particle physics needs to have a slightly different explanation because obviously somebody is interested in this model. I'm just simply going to state so that you understand, although I covered this in the last couple of lectures, basically with tirades and rants because I hate this situation. The reason why this incredibly non-understandable, convolute, complicated system of models has been developed, not just in cosmology, which is really a separate case, but in particle physics, we're talking about a specific need felt by a specific investigator. So here you have to follow the money trail. The Large Hadron Collider is on the order of $10 billion, and now a circular collider is in the works, and it will be developed and probably deployed by the year 2028. It will be vastly larger than the Large Hadron Collider, and its circumference will go underneath Lake Geneva, completely dwarfing the Large Hadron Collider. The amount of money that will be spent on this is astronomical. And so the question is, who is funding this? Sabine Hossenfelder has pointed out consistently over the past many years that she's a thorn in the side to the particle physicists because she keeps saying that the Hadron Colliders are an entire waste. Now, in the case of the Large Hadron Collider, she kept her cards a little closer to her blouse because she was able to, I guess, force herself to admit or concede that the Large Hadron Collider had one purpose, which it partially fulfilled, essentially to complete the standard model. And you've heard of the Higgs boson. We're not going to go into that aspect of the standard model, but it's important to understand where the standard model comes from. It comes from industry. It's an industrial exploit. And the reason for the incredible outlay of money, which should, of course, be being used by the governments who support the colliders. It should be used for humanitarian purposes, just standard everyday life. Not necessarily giving money to the poor, but giving money back to the people who earned the money in the factories. That money does not go back to the people. When it goes into the government pocket, it then is turned over to those who are seeking political ends. And this is, of course, a weapon. So the Large Hadron Collider is a military installation. That must be conceded. It's obvious. But you see, that raises political controversy, which we scientists really don't care about. If you have a humanitarian aspect, such as I would have to say Sabina at least supports, that's your business. But it certainly isn't science. It's something that humans do. Well, I don't, because I know I cannot fix the situation or in any way influence it, except with the obvious indirect method of getting the truth that we all want. All right, so that's where the standard model of particle physics comes from. What I'd like to show you now is just a little visual aid, and this is basically taken from internet sources. This is a copy paste that you see at the top where it says particles in the green box, and then it splits into two boxes called the fermions and the bosons, or bosons. In the many times in the near past that I've sought to penetrate the standard model of particle physics, very often for a specific reason, to understand what someone was saying about something that I needed to understand better, I found it quite frustrating. And due to the way I perceive my role in science, which is something of a teacher or guide, this is not something extraneous. I do this for myself. I'm also teaching myself. And I found certain methods that I find congenial, useful, efficient. In the case of the standard model of particle physics, I find that the terminology is grossly misleading. It's extremely confusing. What I intend to do today for you, as well as for myself, as I review this, it always does me good to review what I've already prepared. We can make it much, much simpler. I don't find this in any of the standard textbooks. There are no presentations that make this easy. Again, there's an explanation for that, because that's contrary to the interests of a true scientist. I say true scientist, to distinguish us, you and I presume you are wanting to get understanding, is to distinguish us from the military-industrial complex, which certainly is not after understanding in the human sense. It's after a source of power, particularly weaponry, obviously. That's not speaking out of class. We all know that, and we just simply have to be sure that we state these things in the least controversial way that we can. So we're trying to stay out of the controversy over the waste of money on Earth, and of course the inhumanity of man to man, and the enormous evil of governments themselves, despite their obvious advantages. So here we have what I found to be at least a presentable diagram of the model. And you can see that the figure is, let me switch over here so I can point things out. Right here above where you see the highlight, the next line up, which I cannot highlight, is the classification by standard model. That's actually a poor translation. The man who composed this document was Turkish, I believe, and the translation of his document, only 8 pages long, which is why I selected it, the translation was exquisitely bad. So don't worry, I've taken care of all that. But down where you see it says factoids, that's just disregard, that's just my word. I have this numbered 1, 2, and 3. Number 1, the first thing we learn from the model, everything is a particle. That's incredibly important. If you've been following my lectures at all, as I've drawn out for view a spherical model of the universe, that is, a spherical model of a spherical geometry, which is necessary now. To say that everything is a particle shows bias, because if you say everything is a particle, you're contradicting what science already knows. So right at the outset, the model is wrong. Not everything is a particle. But you see, this gives us an incredibly powerful grip on what the model is. It starts out by denying its legitimacy. To begin by saying that everything is a particle makes it wrong. And everything to follow is absolutely incorrect. So the model is not just flawed. Now, when Sabina and other top-notch presenters of real science attempt to talk about the flaws in the model, these are internal flaws in the mathematics. But the model itself is invalid. So you can disregard all the flaws in the model, and we're not going to talk about the flaws in the model. We're simply going to understand what the model says. It starts out by saying it's anti-scientific, it's anti-geometrical, it's contrary to all the known principles of physics. It begins as a nightmare. That everything is a particle, that explains a lot. It really does. So the standard model, particle physics cartel, is not a scientific cartel. It's an anti-scientific cartel in order to achieve political goals, a weapon, power, political domination. It's very interesting that the Large Hadron Collider, and within probably 4 or 5 years, the Circular Hadron Collider, which will be enormously more expensive, they're in Switzerland, but they're partially in France. The Hadron Collider cyclotron actually crosses the border between Switzerland and France more than once. The reason I bring this up is it's possible that the site was selected partly because it's in Switzerland, which keeps it somewhat or relatively out of reach of political trouble that may affect the collider's upkeep. But also, it's partially in France and partially in Switzerland. So, by its very position, its geopositioning, it's an international installation. Alright, so that's enough on the Hadron Colliders. But this is merely to point out where the model fits into the bigger picture of what science is doing. This is not science. Unless you're willing to concede that the technological side is science. I do concede that, but I make a careful distinction between technology per se, which is its own world, and science. These overlap. But the only reason that technology needs science, which is based on rational logic and human needs to get understanding, there is no overlap there. Technology has no desire whatsoever to serve human needs. But this is a primary human need, as I've pointed out. This has a religious overtone. It's a conflict between two religious axiomatic bases on behalf of humanity and every individual human. I reject technology for that reason. I understand its value, but I also completely understand, as you should as well, that it has failed humanity. It's being used, as was predictable, more for evil than it is for good. It is true that we get cars and jets and electricity, all of this is good, showing that technology was meant to be good. It was meant to make this planet much, much better. That's partially been the case because we do have jets and we do have electricity. However, we also have thermonuclear weapons and extraordinarily sophisticated methods of mass murder, which are being used now, and I'm going to stop there. You know where it's being used. It's not Ukraine that matters, although it does. They're humans. It's the Gaza Strip. All right. So the standard model begins with the statement that everything is a particle, which is incorrect. The next level down, you'll see in yellow and magenta, the fermions and bosons. So you know where these strange words are coming from. Bosons originated as a term. The term boson or boson comes from a man named Bose. I believe he was from India, and he had a statistical analysis method for subatomic particles. Fermions, you may have guessed, is named after Fermi, and Fermi and Bose are physicists. So that's where the names come from. What they refer to are two statistical methods of analysis. And the fermions are considered to obey Fermi statistics, whereas bosons obey a different system. It took me quite a few shots at doing this, and it was only on the last couple of shots in trying to penetrate what this model is trying to say that I began to understand, and now I do understand, that the bosons, first of all, cannot be particles. And you'll see that on the two lines that come out from the green box saying particles, you'll see that to the left it says matter. And so it's referring to matter particles or mass particles, but they don't say mass because they use the term mass differently than is accepted in classical physics. So this deviates almost at every single level from what is known and accepted and what is actually true. Again, there are reasons for that. It's because of mathematics. So that's all we'll say there. Now, the bosons can be completely discarded. There's no such thing as a boson. And the reason for that is that you'll see that it says it's representative of a force. These are called force carriers or force particles. That's a direct contradiction to what we already know, and it's completely anti-scientific, but apparently not anti-mathematical. It is important to explore that just a little bit so we understand at least what's being said when the term boson is used. It is a force carrier, and it is, of course, then a particle. These are assumed to exist because they must exist because the model apparently demands it. I'm not going to even try to understand yet why they think so, although to give you, just to be frank, I'm pretty sure I know why they do that. But you'll see there are 4 kinds of force particle. And one of them you've heard of, the photon. And the other 3, if you haven't heard of them, don't worry because you don't need to know about them, except in order to know what they're saying. So I'm going to tell you what these things actually say, and this diagram says what they are. There are considered in the standard model, this is a standard model of forces, there are 4. That is also incorrect. I've proved that there are exactly 2 forces at the axiomatic basis, and they're both spherical forces called centripetal force and centrifugal force. However, to be fair, what is being talked about here is subatomic particle dynamics in order to get the power out of it. What is being sought in the Hadron Collider experiments and in the production of the model that goes with it, which is what we're looking at, the goal is to get to the strong force. And that's one of these four forces. The four forces that are conceived incorrectly, but in their system, this is the only way they've chosen, somehow it comes out. There's a strong nuclear force, a weak nuclear force. These are new. These are quantum conceptions, essentially. I'll put it that way. They're not real except in a mathematical construction, and they're not part of physics, but they are part of this model. So that's where we get these two highly touted, highly deviant ideas. These are not correct. There's no such thing as the strong nuclear force or weak nuclear force, although I will show you there is a strong nuclear force, you could put it that way, but it's not negotiated by a boson, a force particle. It is actually a force, which, when you're talking about a force in real physics, it's a field. A force is a field. There's a footnote to that, but we're not going to go into that great detail. You'll see on the far right, there's something called gravity, which you've heard of, but above it, it says graviton. This is a hypothetical particle, and that is in parentheses in this diagram. That has not been discovered. Of course, it never will be discovered, and that's one of the... It's very useful. It's very useful to say that there must be a graviton, because that gives a justification in the support of this military-industrial complex that they're able to say to the public, we're working on gravity. And that's where you get supersymmetry, and that's where you get string theory. They're all part of the lie, and this is an advanced system of deceit and lies. That is what the system is. All we're trying to do is understand the nomenclature that they use to support their system. It doesn't mean we have to believe these things in any way. Now, there would then be four particles to represent these four forces, which are claimed to explain everything in the universe. Completely ridiculous statement. But one of them is the photon. So the photon is considered to be a particle, which is incorrect. It's considered to be a force carrier. That doesn't really mean anything. But what's in magenta below the word photons? It says electromagnetic force. So the photon is considered to be the carrier particle of electromagnetism. It's a very interesting thing to say. It's not entirely incorrect, because a good system of lies will not be entirely lies. It will have some truth in it, so as to convince, first of all, those who wish to support the model, who think they're doing well, and secondly, to convince the public, through the mouths of these poor sycophants, that this is actually important. Okay, so those are the four categories of force particles. The photon is considered to be one of them. It's for the electromagnetic force. The WZ bosons are for the weak nuclear force, and the gluons are for the strong nuclear force. That's really the central, that is the target. What these scientists are after as they serve the Godfather, who's trying to murder pretty much everyone on Earth except for one government, whichever one that is, and we're finding out which one that is pretty quickly in 2024. But for whatever reason this system is being promoted, what they're after, they call gluons, because the gluons negotiate the strong nuclear force, which is the theoretized source of the next weapon, the next source of power. So that's why you hear a lot about gluons. They don't exist. Now, we can disregard that entire side because there's no such thing as a force particle. That's a direct contradiction to physics, which has already been proved. So that is a red herring. That cuts off 1/2 of the system at this basically tree split. It's a binary split in some sense. And 1/2 of the tree we can throw out because it's contradictory. It makes no sense. Now we turn to the left where it says matter particles. And I've already mentioned they prefer the word matter to mass because mass has a specific meaning in the model. Whereas matter, it's a replacement word. These are called fermions for reasons we've already outlined. And now it splits into these two. I'm pointing, but you can't see the pointer, I'm sorry. But you'll see right below fermions, it says quarks and leptons. So this begins a new tree. It's the side of the tree that we need to understand better, having discarded completely the boson branch of the tree. So I'm going to switch over now and scroll up. I'm just going to read this so I can scroll a little further to get down to where you see there's an expanded diagram. A particle. All of these are particles. We have a force particle, of which there are 3 because the graviton has not yet been discovered. So there are 3 bosons in this model. The 3 are called, I have them S, W, and EM. The weak and the strong forces we can disregard, but electromagnetism, I've put that in capitals. The photon corresponds to the boson for the electromagnetic force, and the other 2 we've already covered. We throw out this entire blue area, it means nothing. Here we have the matter particles called fermions, and I have put that over here. There are 2 fermions, or I should say 2 classes of fermions. The quark and the lepton. There are 6 quarks, and these compose what are called hadrons. And hadrons are distinguished from mesons and baryons because hadrons, let me back up here, the quarks, the 6 quarks, compose themselves in 2 different ways. And because they compose themselves in 2 different ways, one of the products is called hadrons. And that's a 3 quark system. The mesons are 2 quark systems. So I put that in parentheses to show that that's a second kind of quark construction. But the main construction of the quarks is a 3 quark system, which then is labeled hadrons, but that includes the mesons. If you disregard the mesons, the hadrons and the baryons are identical. So that's why you hear about baryons. But the hadron colliders get their nomenclature or their title from this 3 quark matter particle. So a hadron essentially is a baryon, disregarding the mesons. The mesons are composed of a couple of types, one of which is the pion, and Sabine Hussenfelder talks about that in one of her latest releases on this subject, which is worth listening to. Now in red, I've highlighted the proton because that is a particle. So the way the proton fits into this schema is as a mass particle called a hadron, also called a baryon. So that's a proton. E, as you can see I've highlighted here, refers to the leptons. Leptons, I give the abbreviation E here. And under the lepton construction, which is a quark construction, I'm sorry, it's not a quark construction, it's separate from the quarks. These are a different kind of particle. Quarks really shouldn't be called particles, but this whole system is self-described as nothing but particles, but quarks are particles that make other particles. The lepton is not. The lepton is considered to be a basic particle. It's a basic mass particle. So when the mass particle is constructed of quarks, it leads to their definition of the proton. When it's a lepton, that's an electron. But it also can be one of these. And I call this the tau-muon neutrino system because there is a tau neutrino, a muon neutrino, and there are all kinds of combinations of tau-muon neutrino things. You can disregard that. So essentially we found the two mass particles. According to the standard model, the proton is a hadron baryon, which is redundant. The electron is a lepton. So now I'm going to scroll a bit further. You can see this is the bottom of the page. So you see that's the bottom of the diagram. Now here where I'm highlighting this area, I'm just going to scan it with you so you see what I've at least written here. We can understand the standard model of particle physics much better by pointing out a few things right away. First of all, not everything is a particle, so that's incorrect. And then no force particles exist, so we need to point that out. However, I have a note that the photon is considered to be the carrier of the electromagnetic force. There is some substance to that statement, but we're not going to cover that in great detail now. So the correct way to approach this model is through the subcategory, one of the two sides. Not the force particles, since that's a direct contradiction of physics. But the standard model of matter particle physics is what this should be now called in our construction. So I'm calling that MPP for matter particle physics, and that's one of the two of secondary tiers which we're elevating to the top tier. So we're not talking about force carrier particles since they don't exist. We're talking about matter particles to see how much of this might actually exist. So now we have a heading, the matter particles. We've simplified this model, and we're talking now only about the fermion branch. These are the matter particles. There are 3 bosons, just to finally dispose of what we need to just get rid of. There are 3 bosons, but there's not a graviton yet, but they put the photon into that categorization. Completely incorrect. There are 2 fermions, the quark and the lepton. So now we can say that the matter particles are classed as quarks and leptons. Now here in the diagram you'll see that. I've simply taken out part of what you saw before, and in blue, right below fermions, you'll see there are the quarks, of which there are 6, and the leptons, which we can completely disregard, except to note that that is where the electron goes. So now we know how the standard model of particle physics classifies the electron. It is a lepton matter particle. That, of course, I've already disproved. Now for the quarks, this is where it really gets, I would say, interesting, but whether you agree or not is entirely a matter of taste. We're only interested in the facts, not in how attractive the mathematical system might be, because that's extremely deceptive, as of course we now know. So there are considered to be 6 quarks, mercifully abbreviated here. It's basically up, down, top, bottom, charm, and strange. The history of this naming convention is somewhat humorous, but I am not amused, so we're not going to go into that here. The quarks compose themselves into hadrons, which then serves merely as a pseudoclass for the mesons and baryons. So quarks make themselves into either mesons, which is a quark and antiquark, which then are called pions and kaons, and the etc. is sad, etc. there. There's no such thing as mesons. But underneath the hadrons, when they make a 3-quark system, that's called a baryon. And those are called protons. Here it says protons and neutrons, but if you've been following along my lectures, you know that the proton and the neutron are the same particle in two different states. And now here you'll see a little bit more information to expand on the concept of the fermion, which gives us the position in this model for the two particles that we do know of, the electron and the proton. The electron is considered to be a 2-quark construction, and the proton is considered to be a 3-quark construction. So of the leptons, only electron is important. The other ones are called the tau neutrino, the muon neutrino, the electron neutrino, the tau, the muon, and the electron. So those are basically the 6 leptons, only one of which has a name that you and I need to be aware of, and that's the electron. However, you'll notice there the word neutrino appears 3 times. That's a major selling point. It's equivalent to the graviton. They seek it. And I won't go into that because it's a sad story of a waste of money and a waste of time. So only the electron is of any importance at all in the lepton category of the fermions. Now the quarks make not only the quarks. This is what used to catch me, is I couldn't quite, for the longest time, understand the quarks are not particles, but leptons are. Now in this model, everything is a particle. So this was to me, I guess due to some limitation in my ability to logically penetrate this monstrous system. But quarks basically are what make hadrons. But of the hadrons, the mesons are a quark-antiquark construct which we can disregard. So you can go straight down this left line from quarks, which make hadrons, which make baryons. And the baryons are the protons. And that's the end of the model. That is the totality of the model. So I sincerely hope this has helped you. It's helped me not only to explore this, but to explain it again to you. That's always of value to the presenter. Because of the nature of our hearing system, we actually hear our own words. This is a very good way to certainly solidify one's understanding. Never hurts to repeat. The essence of education is reliant to a certain degree on repetition, for memorization, for understanding. Memorization is a convenience. So you don't have to keep reinventing the wheel. You start to remember the things that you do understand, which then encapsulates a whole system of understanding on which you can build. So that ends our presentation for today at just under an hour. I hope you enjoyed this. This is Anagalactic bringing you the secrets of the universe, and now attempting to bring you the secret at the inner edge of things. in order to understand light, and so I'll close this off to round this out at an hour, to tell you where we're going. We are attempting to understand the structure of the universe, which of course is huge, and that could be a daunting prospect, but we're able to classify our approaches, our strategies, so that for me, just speaking strictly for myself, I've devoted my attention to astronomy, which is in a class by itself, and it's the largest spatially, certainly, but astronomy has fascinated men since the beginning of time. So I need make no apology for concentrating on astronomy. What has made this so interesting to me was at a turning point because I wanted to understand better the information we get from heaven. That is starlight, which goes to galactic light composed of stars, and further structures going out, which are made of stars. However, there is another object, a luminous object, which has been discovered that I'll be covering in great detail because it's the cutting edge of real science, real astronomy, real physics. It's called the quasar. And it's the only other luminous object in the universe that's been discovered thus far. It's pretty safe to say we're not going to discover any more luminous objects. But in the 1960s, a new luminous object was discovered, which is now much, much better understood. This being now, 70 years later, 60 years later, the quasar is a galactic scale luminous object. It's closely associated with a black hole, and I was surprised to find recently that is starting to be admitted. However, the way of the cosmological model is very similar to the particle physics model. They've developed a model based on mathematics, which of course, as you know, leads them to the model that is based on a Big Bang. That has been disproved. It was never a real theory, but it's never going to go away for the same reason that the standard model of particle physics will never go away, because it serves industry, because industry serves the governments, of which there is now one emerging as the winner. And I won't say what that is, but I'm certain you could guess. All right, that's the quasar in the schema of astronomy, the latest discovery, a new luminous object closely associated with the galaxy, closely associated with a black hole. I have a new theory, which I believe is extremely substantial, if not self-evident. You can't really see anything as self-evident, but it's a much stronger theory than the cosmological model currently in place because it explains things in physics, logically, geometrically, and mathematically. So we have a new cosmology emerging. I will say, not to pat myself on the back, but simply to state things the way they are. It's due to my research. A new basis of physics, which goes around these absurd models, very misleading, highly deceptive, anti-scientific models. But the nature of light, we're all working on, I'll just say in our own way. Men have been fascinated with light since the beginning of time, but it really began with Christian Huygens. Newton had something to say about light, and then Einstein, of course, did, and so did Maxwell, and everyone since has been talking about light. We got the term photon from Albert Einstein, but to say that the photon is a particle is part of that model. It also is considered to be proved. I'm going to unprove it and show you the correct way of seeing the particle nature of light. It is real, you could say that it does exist, but it exists infinitesimally, only at a very specific moment in Planck time that light could ever be considered to be a particle. But there's a strange twist there. The only way we can measure light is as particles. According to the linear mathematical system that we've inherited and use now, I have a new mathematical system which takes care of the curvature problem, which so far has been impenetrable to linear mathematics. And that's 1 hour. Thank you for tuning in, and we'll be back soon with a full discussion of light. Going to a seemingly unconnected, unrelated topic, the quasar. They are strongly correlated. We need to know the structure of light, everything about it, and by doing so, I have shown that you can then understand the light of the quasar, which has a different signature from any other light that we get from the universe. The quasar light is extraordinary, and you need to understand, as I have needed to understand, the geometry of light in order to understand the astrophysical object called the black hole. The black hole is one of the most amazing phenomena ever discovered. Currently, it's safe to say, and I will simply characterize it this way, the black hole is completely misunderstood. There's no understanding of the black hole beyond the facts that we've gotten about it, which are enormously misinterpreted, largely due to the lack of any geometry to explain it correctly. This has to do with a concept called the singularity, which is blamed on Einstein, and that's somewhat fair. I've solved that. So I've solved the mystery of light, and I've solved the mystery of the quasar. And that'll be in the next lecture. This is Anagalactic. We'll be right back, and thank you again for tuning in. I appreciate it that I have listeners. It means a lot to me. I'm not sure if that's just my emotional constitution. I don't care. I am human. Thank you.